Hello students, let's do Pythagoras Theorem, exercise 18, questions 11 to 14. Exercise 18 and we are on page number 208, question 11. In the given figure, AD is equal to 13 centimeters, BC is equal to 12 centimeters, AB is equal to 3 centimeters. Now we have got it all here. An angle ACD, which is that ACD, that is this angle. This angle is equal to angle ABC, that is ABC, that is the angle here, and both are equal to 90 degrees. So this is 90 and this is 90. Now we have to find the length of DC. Now DC is here, we have to find the length of DC. So to find the length of DC, we have to know the length of the hypotenuse, which is already given, and we need to know the length of AC also. We don't have the length of AC. Okay, so to find the length of AC, we have to make use of this triangle ABC. So let's begin by saying AD is 13, BC is given, AB, and all this is given. This is already there in the question. So we have written down what has been given to us. Now, in the right angle triangle ABC, we're talking about this triangle first because with the help of this triangle, we're going to get AC. And then only with the help of AC and AD, we are able to find DC. That's why we are first looking at this green triangle ABC. In the right angle triangle ABC, AB is given as 3 centimeters and BC is given as 12 centimeters. Now this is the right angle. So the side that is opposite the right angle is the hypotenuse. So according to the Pythagoras theorem, the square of the hypotenuse, that is AC square, will be equal to the square of the other two sides. So that's what we've written down here. Now let's substitute the values. Now AC square we don't know, so we will write it as it is. So this will be AC square is equal to, now AB is 3 centimeters, so that is 3 centimeters, that one the whole square, plus BC. How much is BC? BC is 12 centimeters. So that is the whole square. So now let's find AC square is equal to, now here I'm not going to expand, I'm going to do it directly. So 3 square means 3 into 3, that is 9 centimeters square, plus 12 into 12 is 144 centimeters square. So now we can find the value of AC square when we add up these two. 144 plus 9 is 153 centimeter square. So what is the value of AC? AC is equal to 153, the square root of 153. Now the square root of 153. Now 153 is not a perfect square. That means there is no number that when you multiply twice will give you 153. You cannot get the square root of 153 as a perfect square. Let me work it out and show you. Okay, so let's try and get the prime factors of 153 divided by 3. 3 5s are 15, 3 1s are 3. Continue with the division. 3 1s are 3, that is 2 left, 21. 3 7s are 21. Continue. Now 17, we have 17 1s are 17. Now, if we have to try to find the square root of 153 by using these, we will get 3 into 3 into 17. Now here we can only pair up the 3's. 17 doesn't have a pair. Can you see 17 is by itself? So we cannot get a perfect square for 153. So we're going to leave 153 as it is. So we're going to say AC is equal to the square root of 153. So let me write it here. So AC is the square root of 153. Now we are asked to find the length of DC, isn't it? DC. So now we have AD and we have AC. We can find DC or CD. So let's do that. So now we're going to look at the right angle triangle ACD, and we said that AC is equal to 153, the square root of this. This is what we found out, isn't it? That AC is the square root of 153. Now that we know the measurement of AC and we know the measurement of AD, we can now find the measurement of DC. So let's write what's given to us. AD is 13 centimeters and AC is the square root of 153 centimeters. Now we're going to use the Pythagoras theorem. According to this theorem, the square of the hypotenuse, that is AD square, will be equal to the sum of the squares of the other two sides, that is AC square plus DC square. So AD square. How much is AD? AD is 13 centimeters. The square of 13 centimeters will be equal to AC square, and AC square is 153 centimeters, the square root. Now the square of this. So AC is the square root of 153, but here it says AC square. So that square plus DC square. DC is what we are going to find out. So we will write it as plus DC square. Now here 13 into 13, that is 169 centimeters. Now this one, 153, the square root of 163 square. Now look at this. Let me give you an example. Suppose I have the square root of 9 and I say the square of this. So what does it mean? Square root of 9 into square root of 9, isn't it? Now we know that 9 is a perfect square. What is the number that will multiply to give us 9? 3 into 3. 3 threes are 9, isn't it? So square root of 9 is 3, and here also square root of 9 is 3. So 3 threes are 9. So here what did we get? When we say square root of 9 the whole square, the answer is simply 9. Okay, so did you understand? So what did I do here? Square root of 9, the whole square means square root of 9 into square root of 9. And the square root of 9 is 3. Square root of 9 is 3. 3 threes are 9. So straight away, when you have square root of a number which is squared again, the answer is 9. Similarly here, you have the square root of this number which is squared. So the answer will simply be 153. So this is 153 centimeters plus DC square. So this is going to be, we're going to take only DC square because we need to find DC, and on the other side we have 169 centimeters. We're going to minus 153 from it because we have transposed it. So now we can find the value of DC square, that is 169 minus 153. And that is equal to 16. So if DC square is equal to 16, how much will DC be equal to? It will be the square root of 16. Now what is the number that when you multiply by itself gives you 16? The answer is 4, isn't it? So the square root of 16 is 4. Now let me also work it out for you in the prime factor method. So let's find the square root of 16. So let me take 16 and find all the prime factors. 2 8s are 16, then 2 4s are 8, 2 2s are 4, 2 1s are 2. So this was equal to, there are 4 2s, 1, 2, 3 and 4. Now let me pair the 2's. So I have one pair here and one pair here. So the square root of 16 is equal to, remove the square root sign, take 1 from each pair, 2 into 2. Square root of 16 is 2 2's are 4. So that's how we found DC is equal to 4 and the unit is centimeters. So DC is equal to 4 centimeters. So this is our answer. Question 12. A ladder 6.5 meters long rests against a vertical wall. Okay, so look at this figure. This is the vertical wall and there is a ladder that is resting against this like this. Okay, if the foot of the ladder is 2.5 meters from the foot of the wall. So this is the foot of the wall and this is the foot of the ladder. It is 2.5 meters away from the foot of the wall. Now the question is, find up to how much height does the ladder reach. So what is the height of the ladder? The height that the ladder will reach. So this is what we need to find out. So length of the ladder is 6.5 meters. Length of the foot of the wall, okay, of the ladder from the foot of the wall is 2.5 meters. Now we are going to use the Pythagoras theorem because here this is 90 degrees, the foot of the wall here, and the side that is opposite that is the hypotenuse. So we can use the Pythagoras theorem. According to this, BC square should be equal to AB square plus AC square. So let's substitute the values here. How much is BC? BC is 6.5 centimeters. So that means 6.5 centimeters square is equal to AB square, which is 2.5 meters, the whole square, plus AC square, which we don't know and we are going to find out. So here 6.5 meters square means 6.5 into 6.5. That is equal to 42.25 meter square, and this is equal to 2.5 meters into 2.5 meters, which is equal to 6.25 meter square plus AC square. Now we are going to find AC square. So we're going to write AC square here as it is. And on the other side, we have 42.25 meters square. And we're going to subtract 6.25 meters square from it. Because we have transposed 6.25 to the other side, it has now become subtraction. So AC square is equal to 42.25 minus 6.25, which is equal to 36. So this is 36 meters square. So now to find the value of the AC alone, we say square root of 36, which is the number which you multiply twice gives you 36. It is 6, isn't it? 6 into 6. 6 sixes are 36. So that means we have found AC to be equal to 6 meters. So this is our answer. AC is equal to 6 meters. Question 13. A boy first goes 5 meters due north and then 12 meters due east. Find the distance between the initial and the final position of the boy. So a boy first goes 5 meters due north. Now let's draw this triangle to help us understand better. Now he's going to move due north. Now where is the north? Now this will show us the directions. North is on top. At the bottom is south. And then here we have west and we have east here to the right. So now north is on top. So the boy is moving towards the top. That is, we'll mark it as AC. So he's going to move upwards from A to C. That is north. And what is the distance they're telling us? Direction of north AC is 5 meters. So that is 5 meters. And then 12 meters due east. And where is east? Look at the directions here. East is down, it comes down to the right downwards. So that means this is the position. So he moves towards B. So C, B he moves. Now here 12 meters due east. So this is the distance. Okay. So from here to here is the distance. So that is 12 meters. So we'll write it as 12 meters. Now we have to find out the distance between the initial position is here and the final position of the boy is here. Now we have to find this distance between the initial and the final position, that is BC. Now let's use the Pythagoras theorem and say BC square is equal to AC square plus AB square. So now let's substitute the values and see. Now BC square we don't know, so we're going to leave it as BC square. Now AC is 5 meters, so that will be 5 meters the whole square plus AB. AB is 12 meters, 12 meters the whole square. So this is BC square is equal to 5 meters square means 5 into 5, that is 25 meters square, plus 12 into 12 is 144 meter square. So let's add up these two and see what we get. BC square is equal to 169 meter square. So now to find the value of BC, we say the square root of 169. So what is the number that multiplies to give us 169? Let's find out by the prime factor method. So we're going to find the square root of 169 by the prime factor method. So 169, let's divide it by 3. 3 by 13. 13 ones are 13 and there's 3 left, 39. 13 threes are 39. Again divided by 13. 13 ones are 13. So here the square root will be 13 into 13. So square root of 169 is equal to, now pair this up and remove the square root sign and take only one number from the pair, so that's 13. Square root of 169 is 13. So we have found the value of BC, the distance between the initial and the final position of the boy, to be 13 meters. So this is our answer, 13 meters. Question 14. Use the information given in the figure to find the length AD. So we have to find AD. So for that we need to know AO and we need to know OD, isn't it? Now we don't have these two measurements, but we've been given other measurements here to help us find OD and OA so that we can find AD. Now AB is 20 centimeters. It's given, isn't it? AB is 20 centimeters. Now CD, can you see? CD is equal to OB or BO, and both are 10 centimeters. If it is 10 centimeters here, it will be 10 centimeters here also, isn't it? So let me write here. So this is also now 10 centimeters. So now that we know that AB is 20 meters and OB is 10 centimeters, if we minus these two, won't we get this measurement? AO, okay, so let's get that. AO is equal to AB, the whole thing, that is 20 centimeters, minus BO, that is 10 centimeters. So let's minus that. So AB is how much? AB is 20 centimeters. And we're going to minus OB from it, and that is 10 centimeters. 20 minus 10 is 10 centimeters. So now we have found AO to be equal to 10 centimeters. So let's write it in the question. AO is now 10 centimeters. So we have found AO now 10 centimeters. Now we need to find OD. Now look at this. CB is 24 centimeter and this is a rectangle. Can you see the 90 degrees? So if it is a rectangle, the opposite sides will be equal. So if CB is 24 centimeters, DO or OD will also be 24 centimeters. So BC is 24, OD will also be 24. So let's write that there, 24 centimeters. So now can you see in this triangle ADO, in this triangle AO is 10 centimeters and DO is 24 centimeters. So now we can easily find this AD by using the Pythagoras theorem. So let's use the Pythagoras theorem and say AD square, that is the hypotenuse square, is equal to AO square plus OD square. Let's substitute the values. Now AD square is what we are going to find out. So we'll leave it as AD square. AO, how much is AO? 10 centimeters. And the square of that plus OD. OD is how much? 24 centimeters. And the square of this. So now AD square is equal to 10 into 10. That is 100 centimeter square plus 24 into 24, which is equal to 576 centimeter square. So now we're going to find out this. AD square is equal to 576 plus 100, which is equal to 676 centimeters square. Now we're going to find only AD. AD will be equal to the square root of 676. The square root of 676. Let's find the prime factors of 676. Let's divide this by 2. 2 3s are 6. Again, 2 3s are 6, but that is 7, so there's 1 left. Now we have 16. 2 8s are 16. Continue with 2. 2 1s are 2. Now there's 1 left, it's 13. So 2 6s are 12. Again, there's 1 left, it's 18. 2 9s are 18. Now we have to use 13, which is a prime number. 13 ones are 13. There is 3 left, so that becomes 39. 13 threes are 39. Again, we divide this and we divide with 13. 13 ones are 13. So what are all the prime factors of 676? 2 into 2 into 13 into 13. Now let's pair this up. So we can pair 2 and 2 and 13 and 13. Now the square root of 676 will be, take 1 from each pair, 2 into 13. That is, 2 into 13 is 26. So the square root of 676 is 26. So here we have found the length of AD. AD is equal to 26 centimeters. So this is our answer. AD is equal to 26 centimeters. So with this, we come to the end of our exercise. Thank you, children.